All right, so a little more homework. This is the stuff from 5-7, which is what most of the rest of this was. It's all 5-7, which is the end of Unit 5, where you just take everything you know and you do it. So the instruction set here is to completely factor over the complex number system. That's your A plus or minus BI stuff. By finding all zeros, the rational ones, the irrational ones, and the imaginary, using rational root theorem, remainder theorem, synthetic division, and the quadratic formula, maybe factoring, okay? It does say in small print, if you have a graphing calculator, you can use it to assist. You're still required to list all the possible zeros. You're still expected to do synthetic division. That still all needs to be there. And I'm going to use my graphing calculator on this to pull out two zeros, okay? I am going to kind of cheat. If you take me next year in pre-calc, that's a class that is designed, the one I teach anyways, is designed to be where you learn how to do everything without technology. That's a little more tedious. What they do, oh, sorry, I have to do rational root theorem. By the way, the rational root theorem is going to be factors of the constant 24 over factors of 2. If this thing has a rational 0, it's in this list that I'm about to create. So factors of 24 are plus and minus 1, plus and minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. And I know kids get a little freaked out when I write things out like this, but 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. I don't think I missed anything else. Over factors of 2, which is plus or minus 1, plus or minus 2. This enables me to create a list of potential zeros. So if I take a 1 and divide it by 1, I still got 1. And I just write down this. I take a 2 over 1, 3 over 1, 4 over 1, and so forth. So I've got the entire numerator. If there is a rational 0, it might be one of these. And then I can go through and divide by 2. So now I introduce a half. 2 over 2 is 1. That's already in my list. 3 over 2 would be new. Plus or minus 3 halves. 4 over 2 would be 2. 6 over 2 would be 3. 8 over 2 would be 4. 12 over 2 would be 6. 24 over 2 would be 12. If this thing has a rational 0, it's in that list. And like I said, in pre-calc, we guess and we plug in. We guess and we plug in. We guess and we plug in. Okay? So I'm going to cheat a little bit. I'm going to pull up my TI-84. I'm going to graph the function because I know that zeros happen when I cross the x-axis. Some people like looking at tables. I like to look at the graph, but I'll also look at the table so you can understand maybe because I think it helps understand. Zoom 6. There is a 0 right here at what appears to be -4, and there is a real 0 that happens right here at 1. I couldn't tell you what these are. But I think there's a 0 here and a 0 here. So I'm going to go look at the table. There is a 0 at 1. Do you see how it says 1, 0? So I know that x is 1, is a 0. These are my zeros. X is 1. And it seems like I saw one back at negative something. Oh, there's 3 actually. This thing actually has pretty much all of them. There's one at -2 and there's one at -4. Anyways, I'm only going to use 2 of them because I actually want you guys to learn how to do the quadratic formula and such like that. So I'm going to use those 2 zeros. There is a third one, all right, -4. And then there's going to be a funky one. I'm going to use these 2 and see what shows up. Notice those were in the list too. One was, and so was -2. I can do something we call synthetic division. I'm going to go after this one first. X is 1. The top of this upside down vinculum contains 2, 13, 19, make sure I don't need any placeholders, negative 10, and negative 24. And I'm going to drop the first one, and then I'm going to multiply. 1 times 2 is 2, and then I'm going to add 15. 1 times 15 is 15, and then I'm going to add 34. I'm going to multiply 34. I'm going to add 24. I'm going to multiply 24. I'm going to add 0. This is my remainder. Because I got a 0, I know that is a 0. I'm going to synthetically divide out the next term from the reduced polynomial. I literally factored something out of there. That's how this works. It's factoring, believe it or not. I'm going to use the negative 2 this time. I drop, I multiply, and I add. So I just did negative 2 times 2 and got negative 4. I added, got 11. I multiply, I get negative 22, and then I add. I get a 12. And I multiply, and I add, and I get a 0. This is my remainder. The remainder is preceded by a constant, which is preceded by an x, which is preceded by an x squared. So I have successfully factored out x minus 1 and x plus 2. And there are two zeros here at 2x squared plus 11x plus 12, so I'm going to set it equal to 0. And I'm going to try to factor it. Factors of 12 are what, 4 and 3? Beautiful, 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 beautiful. 2x times 4 is 8x, 3 times x is 3x, 8x and 3x make 11x. Could have used the QF on this thing too. If I take this one and I set it equal to 0, I get that x is a negative 3 halves. Study that, subtract 3, divide by 2. And this one is just as simple as changing the signs. All right, so all the zeros have been found. I actually have some of the factoring going on. It talks about factoring it. I'm going to write down the two factors I have already written. I have written 2x plus 3 and x plus 4. And then I'm going to glance over here. If a 0 is x equals 1, the factor is x minus 1. And if a 0 is at x equals negative 2, the factor is at x plus 2. We change sign as we enter parentheses. So that was x minus 1 and x plus 2. And that is the complete factorization of that fourth degree polynomial, brought to you by a TI-84 and synthetic division. All right, what's up with this bad boy? Same crap. Do the same thing. The potential rational roots is a really short list. Would be factors of 2, the last number you see, over the factors of the understood 1. Well, this is going to be a short list. To make a 2, it's plus or minus 1, plus or minus 2. Now what I want to do is I want to pull 2 rational roots out of this thing to reduce it to a quadratic. You can actually kind of shortcut your way through this without doing synthetic division, but the problem is it doesn't show you the reduction. That'd be 1 minus 2, which is negative 1, minus 3, which is negative 4. 1 is a 0. What I did is I plugged a 1 in, and I did the math, and I discovered it was a 0, so I'm going to plug a 1 into this thing. My synthetic division, I'd put a 1, a negative 2, a negative 3, a positive 2, and a positive 2 in the second floor of my vinculum. It's called a vinculum, oddly enough. I drop the 1, I multiply, and I add. 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 So I found 1 0, and I need to find another one. If I do negative 1, that would be negative. It's going to be cubed. Negative 1 plus 1, which is 0. That's my x. It's probably going to be plus or minus 2. I'm going to just guess. I'm too tired to be doing this in my head. I'm going to guess a 2. Because you need to see me miss one. I'm going to use this reduced polynomial. I drop. I multiply, and I add, I multiply, and I add, I multiply, and I add. I got -6. So what I just learned I just learned that this is not a factor. The remainder is not 0, so not a factor. Wish I was using pencil here, I'm not, so I gotta do some other words. Maybe -2 is. For that matter, maybe 1 is a factor again. I should probably think about that a little clearer. This would be -2, that'd make -6. No, it's not. Maybe -1 is a factor, or even maybe -2. Anyways, I'm just wasting time when I could just be doing the math. I'm going to try -2. That's going to be +2, 1, -2. Nope, it's not -2. Okay, so let's try -1. I should just cheated with the TI-84, shouldn't I? Been a long day. Drop the 1, that's -1. This is a -1 minus 1, which is -2. That's 2. Ah, there it is. That's -2. There's my 0. This is my reduced polynomial. I have now reduced it down to x squared minus 2x minus 2 being 0. And that thing will not factor. There are no factors of -2 that add to -2. So I get to hit it with a quadratic formula. Opposite b plus or minus square root of b squared minus 4 times a, which is 1, times c, which is -2. All sitting pretty over twice a. So 2 plus or minus, inside that radical is 4 plus 8, which is 12, over 2. If I do my reduction and I simplify my radical, root 12 is 4 times 3, root of 4 is 2, 2 over 2 is 1, root 3. There are my x values. Now I also have this one and this one that worked as well. So now it's time to completely factor. If -1 is a 0, then the factor is +1. If 1 is a 0, the factor is -1. And if you've watched the previous things, you know that when I put these things in parentheses, their signs change. So x minus 1 minus the root of 3 is a factor. That was where I did the plus root 3. And the last factor is x minus 1 plus root 3. Because if I take away the negative, it becomes a positive. So there is the complete factorization of that thing. All right, another one of these. 64. I'm going to have to write really teeny tiny on this one. I'm probably going to cheat with the calculator too. Your potential rational roots are plus or minus 8 over plus or minus 1, which is just plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And I am going to cheat with the TI-84. I'm going to grab some things out of here just because I don't have enough room to make a lot of mistakes because I insist on working with an ink pen. That's my stubborn nature. And I'll zoom, make sure I've got it typed in right. Zoom 6 that bad boy. There's actually 4 things right there. They all look pretty nice too. I'm willing to bet the zeros are -1, 1, 2, and 4. But anyways, you've got to do some quadratic formula. So second table, yeah, they're all there. I'm just going to pick on 1 and 2. Okay? I'm going to pick on 1 and 2. I'm going to synthetically divide out the 1. I'm going to drop the 1. Sorry, you can't see what I'm doing. I'm going to multiply, and I'm going to add. I'm going to multiply, and I'm going to add. I'm going to multiply, and I'm going to add. I'm going to multiply, and I'm going to add. And after I pulled out the 1, I'm going to pull out the 2. I'm going to drop, multiply, and I'm going to add. I'm going to multiply, and I'm going to add. I'm going to multiply, and I'm going to add. And remember, this is the remainder, constant x, x squared. We always reduce to a quadratic. So I have x squared minus 3x minus 4 being equal to 0. That factors easily. Factors of negative 4 that add to negative 3 are negative 4 and positive 1. Let me just go ahead and finish this thing off. I had a 0 at 1, so it factors as x minus 1. And I had a 0 at 2, so the factor is x minus 2. That is the factorization of that thing over the complex number system. I've got about 10 more minutes that I can give you. So let's jump into 5-6, which is this one is. Given the volume of a cone below, solve for x. Well, that actually has nothing to do with that particular lesson. That's just some geometry stuff. You probably don't remember how you find the volume of a cone, or any of that stuff for that matter. Maybe you do. It's not on your form quizzes. The volume of a cone is given as, I was sitting here trying to think of how I could explain it. The volume of a cone is given as 1/3 pi r squared h. That's because it takes 3 cones to make a cylinder. And that's not something you can do. You can't take 3 cones and mix them together and make a cylinder. It's just something that we've figured out over time. It was figured out a long, long time ago. It probably wasn't proven until maybe around the time of Christ, but we've known it for thousands of years. But anyways, plug some crap in. The volume is known to be 125 pi. 125 pi equals 1/3 of pi times the radius, 2x minus 5. That is squared times the height, 3x. I don't know why I wrote pi over 3. I'm going to fix this first off by noticing that that 3 and that 3 cancel. So now I have 125 pi equals pi times 2x minus 5 squared times x. And I'm just showing you all the nitty-gritty little steps. The pi's cancel. Divide pi on both sides. And you're going to have to write this thing twice. If you FOIL out 2x minus 5 times 2x minus 5, you get 4x squared minus 10x minus another minus 20x plus 25, and you still got this x to deal with. So, x everything. You're getting a little bleed through there. It's probably getting harder to see this. 125 equals 4x cubed minus 20x squared plus 25x. Going to shift that 125 over to the other side. It'd be nice if I made this problem to factor. And I believe I did. I wonder how long it took me to create this problem so it factored. I did this a long time ago. But I did, and it does factor. It's called factoring by grouping. Both of the leading terms contain a 4 and an x squared as a factor. So I can pull an x squared out. I can actually pull a 4 out. If I pull a 4x squared from 4x cubed, there's an x remaining. If I pull a 4x squared from minus 20x squared, there is a minus 5 remaining. Now I shift to the back. Both of those contain at least a 25, sorry. So I factor 25. If I factor 25 from 25x, I have an x. So I factor from negative 125, I have a 5. Now I can finish it. I've gone from 4 distinct pieces to 2 distinct pieces. And both of these pieces contain x minus 5. So I factor it out of here. And the crap left over is 4x squared plus 25. I use my cover-up technique, and bam, x is 5. I don't have to figure these out, because if I was to do such a thing, I would be dealing with the concept of imaginary numbers. If you're curious, I get plus or minus 5i over 2. You can figure that out on your own. That doesn't matter in the real world. Just this dude. So, moving on. 62 has got some notation at the end of course tests seem to love. Man, it F's with kids. It's F notation, which is why I'm pushing it so hard. But it says, given that f of 2 is a 0, what are the other zeros of f of x? So what does this mean? F of 2 is 0. That means that x is 2. It means x is 2. Because it's a 0, it also means that x minus 2 is a 0, better known as a factor of the polynomial. All right? Now, that actually had nothing to do with this, but it means that x equals 2 is a 0. And this thing isn't asking you to factor, it just says what are the other zeros. So synthetic division is your best friend. 2, 1, negative 5, 12, 36. Synthetically divide out that factor x minus 2. Drop, multiply, and add. Multiply and add. Oh, that's supposed to be a negative 12, isn't it? I almost had a sign mistake. That bleed through on the ink is starting to give me problems. Negative 18, negative 36, 0. We are left with x squared minus 3x minus 18 being equal to 0. And that bad boy factors. She factors as x, what, minus 6 and x plus 3. There's your two other zeros, right? If I use the zero product property, my other zeros are x equals 6 and x equals negative 3. I like 61. 61 is a very cool application of synthetic division. So a box is given to you, and you're supposed to find the missing side length. The equation for the box is given, which is a rather interesting way of giving you something, but the equation that represents this box is given, at least the volume of this box. And your job here is to find the missing side length. So we're going to use synthetic division, and I gave you this two of the sides, and if a side or factor is x minus 1, then x is 1. If a side or a factor is x plus 6, then x is negative 6. I cannot talk. Anyways, the hint is to try using synthetic division. I'm just looking to see if I have to have what's called placeholders here. It's where you make too big of a jump at once. We haven't run across that yet. So synthetic division, 1, 13, 34, negative 48. I'm going to pull out the 1 first because it's small. So I drop the 1, I multiply. I add, I multiply. 1, 13, 34, negative 48. I had a brain fart, that makes 48. I multiply and I add. So by pulling out a 1, I reduced it to 11448, which likely factors. You could probably figure it out from here on out. But anyways, there's no need to. You can just synthetically divide out the negative 6. I drop, I multiply, and I add. I multiply, and I add. So this is my remainder. A remainder is preceded by a constant, which is preceded by an x. This is literally your other factor. Your other factor is x plus 8. Ta-da! Magic of mathematics. What's it say? It says given a 0, factor completely. So it's a lot like what I did in 61. So I'm going to synthetically divide out a 7. I'm going to drop. I'm going to multiply, and I'm going to add. I'm going to multiply, and I'm going to add. And I'm going to multiply, and I'm going to add. And now I'm going to factor. I'm going to think about what this thing is. This is 10x squared minus 11x minus 6 being equal to 0 because remainder, constant, x squared. I'm going to try 5x and 2x because I made the problem. And for 6, 3 and 2. And that works, I think. Minus, plus. So 5x plus 2 and 2x minus 3. I'm okay with that. So 5x plus 2 is a 0. Wait a second. It just says completely factor, doesn't it? All I got to do is bring this sucker down. If x is 7, the factor is x minus 7. So there you go. Last one I'm going to do for today. Same as the last two. Meet the new boss, same as the old boss. Pull out that one given factor. By the way, I'm just going to jump on down to the end here. That's a 0, which means that x minus 10 is a factor. Okay? Drop, multiply, add, multiply, add, multiply, add, drop, multiply, add. Repeat forever. DMA. I wish it was DAM. It'd make my day a whole lot better if I could say that all day long. I have reduced this thing to 4x squared plus 15x minus 4. That's where the other two zeros are, so completely factor it. And what do we want to do here? Probably 4x and x. I feel so confident in that I'm going to write it right here. Because 4x times x is 4x squared. I think I'll put a 4 there and a 1 there. The outside would make 16, the inside would make 1. Positive, minus. Factored completely. And that's it for the day, kids. I got no more time to give you today. It is time for me to leave this place. You have had too much of my soul already. But I do hope you learned something. See, that was 27 minutes.